Day 4, Problem 1. The Smiths have a 5-foot by 8-foot porch on the front of their house. They are building a similar porch on the back with double the dimensions. What will be the perimeter and area of the new porch? Well, if this is a top view of their house, it doesn't say what shape their house is, so I'm kind of just having fun here, drawing a floor plan of their house. We're told that on the front of their house, perhaps this is the front here, they have a 5-foot by 8-foot porch. Okay? And so they have a rectangular shaped porch on the front of their house that is 5 feet wide and 8 feet long. So it's this rectangle here that is the porch on the front of their house. Now on the back of their house, which is this side here, they're building another porch, or maybe it's a deck. It's also going to be a rectangle, but it has double the dimensions. And so there is a larger rectangle here on the back of their house, like this. Okay? If it has double the dimensions, then its width is 10 feet, and its length, instead of 8 feet, is 16 feet. And so it's this rectangle here that is that porch on the back of their house. Okay? And with these dimensions, we can find the perimeter and the area of this new porch. Let's do perimeter first. To find the perimeter of any rectangle, we can use the formula 2 times the length plus 2 times the width. That would be 2 times 16 plus 2 times 10. 2 times 16 is 32. 2 times 10 is 20. And 32 plus 20 is 52 feet. Now the area of that porch. To find the area of any rectangle, we can use the formula length times width. And that would be 16 times 10, which is 160 square feet. And so we have figured out the perimeter and the area of the Smiths' back porch. Now, day 4, problem 2. A cylinder has radius 3 centimeters and height 6 centimeters. Question A, sketch a picture of that cylinder. Well, here is a picture of a cylinder. Yeah, look at that. All along this year I've been drawing my cylinder sitting upright, and here I've drawn the cylinder laying down on its side, just for fun. It says that the radius is 3 centimeters. So if we put a dot in the center of the circular base and then connect to the edge of the cylinder, that distance is the 3 centimeters. And the height of the cylinder is 6 centimeters. And so height doesn't always mean up and down when you have three-dimensional objects, right? I usually draw the cylinder standing upright, where the segment going up the side would be the height of the cylinder. But if you tip the cylinder over, then the height of the cylinder, which still has to refer to the distance between one of the circular bases and the other circular base, is now this distance. So here is the height of the cylinder. Now in question B, use the formula V equals pi r squared h to find the volume of that cylinder. So for pi, let's substitute 3.14. For radius, substitute 3. And for height, substitute 6. 3 squared is 9. And 9 times 6 is 54. And so we have 3.14 times 54 that we need to figure out. So let's grab some scrap paper and find out 3.14 times 54. 4 times 4 is 16, carry 1. 1 times 4 is 4, plus 1 is 5. 3 times 4 is 12. start the next row with 0. 5 times 4 is 20. Carry 2. 5 times 1 is 5, plus 2 is 7, and 5 times 3 is 15. And then add these rows together. 6, 5, 9, 6, 1. There are 2 numbers to the right of the decimal point. So 169.56. Volume of three-dimensional objects is measured in cubic units, and we are told to use centimeters in this problem. And so our answer is 169.56 cubic centimeters.